in a test tube. And we're going to be doing chemical reactions. One of the cool things about chemical reactions is taking two things, putting them together, and ending up with something totally different. So let me kind of walk you through. And the two places I want you to be looking at here are page 2, which have all of the diagrams with the test tubes, and page 3, which is a data table set. Now, page 3 is where you're going to be including a lot of your observations. And if you notice here, it says is a category where it says products, and then it says precipitate and supernate. So precipitate is a fancy way of saying solid. Supernate is a fancy way of saying liquid. You're going to describe what you see in the lab when you mix things together first in these spaces right here. Now, the products, we have not done reactions yet, but if you flip back to the previous page, let's read together. I'm going to share a couple things with you. So first of all, it says, and we're right here at the top of the second page. It says, in a 100 milliliter beaker, make a water bath by heating until boiling approximately 60 milliliters of water. Now, what you're going to do is you're going to take a hot plate, and we're not using a 100 milliliter beaker. We're going to use a 250 milliliter beaker. So you should see a 250 milliliter beaker at your station, and you should see a 500 milliliter beaker at your station. And measuring a 60 milliliters of water is not necessary. What you should do is just this: take the 250 milliliter beaker, fill it about halfway full of water, and then what you're going to do is you're going to set it on your hot plate, turn the hot plate up to about 8, and that's the first thing you're going to do once you start doing the lab. Don't do it right now, but as soon as you start the lab, you're going to turn it on to 8, put it on there, because in step 5, you're going to need boiling water. So if you forget to turn it on until you get to that step, you're going to be waiting for water to boil, which is akin to watching grass grow. It's not a fun thing to do. We don't want to have you guys doing it. So the question is, why are we making a water bath? That means that someone actually went ahead and turned theirs on. Wait. The fact that it beeped lets me know that you actually turned it on.
That's a smart idea to put that on.
It's good. I guess it's good. So you realize that these hot plates get to about 500 degrees Celsius. And water, you realize water maximum temperature can ever be at is 100 degrees Celsius? Because if it goes above 100, it turns to a gas, right? So we don't want to put our test tube into a 500 degree temperature thing and fry it. We want to do it at a lower temperature. Now, 100 degrees Celsius, still pretty significant temperature, right? But watch, you're going to take a test tube clamp. Can you, there should be a test tube clamp sitting at your table. Can I have that for a second? So this right here, this is the test tube clamp. And it's kind of counterintuitive, because typically when you want to hold on to something tightly, you squeeze it. But here, squeezing it will open up the clamp. So you'll put this around the test tube, and then you'll set it into the water without setting it against the bottom of the beaker. And that way, what we can do is we can heat up the test tube up to 100 degrees Celsius, and that's it. You follow me here? That's what we're going to be looking at in just a minute. Now, it is incredibly important. If you look on the back cart, so for those of you wondering, it's the back cart over there. There are a bunch of dropper bottles, and then on the table behind the cart, you're going to see a plastic container, and then you're going to see some Sharpies next to it. Yeah, so that's where all the materials are. And what I want to encourage you with is read the labels. All the dropper bottles look exactly the same. There are 3 things that we have in this lab that we're working with. One is copper 2 sulfate. Second is hydrochloric acid. And the third is sodium hydroxide. Now, this is a lab where it's going to matter that you are safe. Not that any other lab we don't, but last lab we're working with salt and chalk. And none of you were like, ooh, get salt on me. But you will think that if you're getting hydrochloric acid on you. So a couple of reminders here. You must always have your goggles on no matter what. At no time, in fact, right now, have the goggles go down on your eyes. At no time do you rest them on your forehead. Even if you are not dealing with a chemical, what happens if someone else nearby you is, and you get stuff in your eyes? That would be a terrible, terrible thing. So we're giving you the one warning thing. You have it on over your forehead one time, that's it. The second time, you're gone from the lab and you get a 0. Can I get a head bob here? I care about how safe you guys are. This lab is something we're dealing with, some stuff that can hurt you. Now, let me speak to some safety issues. First of all, when we're heating up, isn't there always a chance of you burning yourself? So if you ever burn yourself on the hot plate, which is, I guess, the thing that probably will cause a burn, if that happens. It's under cold water, whatever you touch under cold water. Now, the acids that we're dealing with, hydrochloric acid, it's a strong acid. And sodium hydroxide is a strong base. Now, you may not think of sodium hydroxide as something like, ooh, like hydrochloric acid has the name acid in it. It seems scary. Sodium hydroxide is just as bad, but in the opposite way. In fact, if you know when you have clogged drains and you have all these hair clumps or whatever, strong bases will just eat right through that as if it's nothing. Sodium hydroxide would definitely eat through stuff. Yeah. Hydrochloric acid is not fun to play with. Just in case you're wondering here, when you read the notes, you see how it says in step 3, if you read it says add 1.0 molar copper 2 sulfate to the first mark on the test tube. The M, that stands for molarity, and that indicates the concentration of whatever it is that we're dealing with. You notice how in step 4 it says add 1.5 M or 1.5 molar sodium hydroxide, and then in step 6 it says add 1.5 molar hydrochloric acid. In each of these cases, it's telling you the concentration of whatever we're dealing with. Just to give you an idea, concentrated hydrochloric acid is 16 molar. We're using 1.5. 16 molar is kind of scary stuff. Like I'd only be using it in the fume hood. Just the fumes from the concentrated acids, they can damage your mucosal lining in your throat and your mouth and nasal passages. So we don't play around with that. 1.5 is obviously way, way less concentrated. Agree? But it'll do the trick. It's still an acid. It's still a strong acid. In fact, I'll tell you, when I was prepping for today, it was on Friday, I was pouring the solutions, and I did a masterful job pouring. I don't want to brag, but it was just brilliant. No drops spilled. Yes, the bottles back there just brilliantly put together. However, I wasn't really thinking about displacement. And if you take a look, we have the dropper bottles, and they have a dropper. Well, I filled up the dropper bottles without the dropper being put in them. And I, in my addled brain, did not realize when I push down into it, it's going to displace that amount of liquid, because I didn't squeeze liquid out and then put it in like I should have. So what happens? I'm holding on to the outside of the container. I push down, the hydrochloric acid comes up over the edge of my hand. Now, I want to share with you what I did. So this is exactly what I expected would happen with you if you did the same thing happen. Went over my hand. I'm like, that's no good. Immediately just went over to I was actually working at this lab station right here. Immediately went over there. I had my goggles on, so I wasn't fearful for my eyes or anything. Put my hand under the water, wash it off. No big deal. I will say that as I was just about to wash it off, I started to feel a little bit of stinging, very light stinging. But once I washed it off, everything was okay. And I have nothing on my hands right now. So if you do happen to get stuff on your hands, then you immediately wash off. Can I get a head, Bob? But to help counteract that, in the back corner there, see those purple containers? Those are latex gloves. So whoever's going to be doing the pouring of the hydrochloric acid, let's just add that level of protection, yeah? So put on the gloves, work with them. Now, if you get the stuff on your gloves, you realize that you can then transfer it to other stuff, so be careful. And then when you're pulling off the gloves, always roll the gloves off. So that way you don't have a potential of touching something that it already is. So you shouldn't have that issue. But I want to let you know that even if you did get something on you, the concentrations we're dealing with are not such that you're going to be like, whoa, and freak out and start running around the room like crazy. You're just going to put your hand under water and wash it off. Where it becomes more tricky is what happens if you get it on your face or eyes. And that's where we have the eye wash station over there in that corner. And what you do is you would push the yellow lever forward and water is going to shoot forward. Now, here's the thing. You better hope that you didn't get any of the acid in your eye, because your eyes will be done. You will still try and take care of them, but you don't really get a second chance with your eyes on that. Can I get a head bob on that? So that's why I'm saying the goggles need to be on your face. Now, what you could have happen potentially is maybe some transference. Like, let's say you're touching chemical with your hand and then you rub your eye. That could get your eye to be irritated. So just be careful. Wash your hands when you're finished doing your lab so you don't get anything into your eyes. Most stuff, like, and the reason I have you guys wearing short sleeves is if you do get something on you, you can always put it under the sink. If you get something on you in a place where you cannot get it off, like your shoulder or your chest or something like that, that's where we have the safety shower. You pull it down over the top of you to get it off. Now, I would caution you here that we're using dropper bottles. So I can't fathom how you're going to end up with it all over yourself. Don't try and show me how you might possibly do that. So at worst, you might be dealing with a drop or two of acid somewhere. Yeah. typically, if you have like pants or some level of clothing, it's going to take a little bit of time before it works its way through because it's not that concentrated. So you should be able with paper towel and water probably get it off. I will say this: one of my groups, one of the steps is when you're adding hydrochloric acid to the test tube. They were doing the test tube and they're moving it, and it fell and it tipped over and spilled the hydrochloric acid all over the table. They grabbed it, so there's still a portion of it still left in the test tube, and they did what they should have done. Immediately, they called me over. And I said, what's in there? And they told me specifically, there's hydrochloric acid in there. So I went over there, and if you can see right next to the eyewash station, there's a white container. Is that white container? That white container is a neutralizer for acids. And literally what I did is I walked over to their station, and I sprinkled the neutralizer over the acid, and it was super fun. It was like watching those volcanoes that you make with vinegar and baking soda. It fizzed a little bit, it neutralized it, and they were able to just wipe it off into the trash because it was just salt and water by the time you're done. You're going to let your instructor know. Now, if I'm not here tomorrow, then that is where you would grab it and put it on there, onto something. But hopefully that won't be the case. Okay, now let's go through these steps here. Everyone okay with this right now? Same thing with the base. You don't want to get on your hands. It's like lye. It'll burn. Wash it off. Again, we're dealing with dropper bottles specifically. Now, in order to help you with this, when you're using your dropper bottle, if you have it open, be holding onto the dropper bottle with one hand while you're dispensing it, and then close it back off. Don't do that salt and pepper trick where you just like put the cap on so someone will grab it and shake it and all pours out. Oh. Screw it down if you don't have it in your hand. I've never seen an open container just sitting there without anyone hand attached to it. Yeah. So let's go through the steps here, and I'm going to kind of walk you through both the procedures and what you're going to be writing in the data table. So step one is to start the water bath, and you're going to start that immediately as soon as we get going. Step two, while the water bath is heating, make 3 marks that are 1 centimeter apart on the test tube. Make the marks from the bottom up. So on the back table there, that's where you're going to find the Sharpies and the ruler. Now, here's what I'm going to do, and we've done this a few classes. It's kind of interesting. So if you take a look at can I borrow the test tube, please? A test tube, any test tube, just grab it up. I was going to say one that doesn't have water in it, liquid in it, but one of the ones that's face up. All right. So if you take a look at a test tube, see how the bottom is rounded? So these 2 groups over here, and by the way, for those of you that are watching, if I'm not here, you're going to divide yourselves into even groups. But and they're going to be at these 5 stations. So the 2 groups over here, you're going to measure from the very bottom of the curvature, 1 centimeter, 2 centimeters, 3 centimeters. The 3 groups that are on this side of the room, you're going to start at where the curvature starts and start measuring from there. 1, 2, 3. So you're going to ignore the curvature on the bottom in terms of the copper sulfate. So you're going to take. See what's that? Yeah. So so you see how it's curved in the bottom, right in the part where it starts going straight. You're going to start, 1, 2, 3 lines past that. So it says add 1.0 molar copper 2 sulfate to the first mark on the test tube. Now the copper 2 sulfate is kind of easy to see because it's blue, and you're going to. But please do me a favor. Even if you pulled the dropper from where the copper 2 sulfate is, read the label, because isn't it possible that copper 2 sulfate is not really copper 2 sulfate but something else? So beware. Then you're going to take the 1.5 molar sodium hydroxide and add it to the second mark. And this is where you start seeing reactions, and this is super cool. Whatever you see happen right there, flip to your data table and see where it says precipitate and supernate for the first step. You're going to write whatever the solid looks like. You're going to write in the place where it says precipitate, and whatever the liquid looks like, you're going to write there. That's as soon as you put the 2 of them together, without stirring or without shaking or doing anything. You're going to write it in here. Now, see where it says products? Well, if you go back to the procedures actually tell you what the products are. So see how it says this. In bold, right here, it says the copper-containing product is copper 2 hydroxide. The other product is sodium sulfate. So when you go back to your data table, won't you put copper 2 sulfate and sodium sulfate in those 2 spaces? So if you're wondering what do I put in here for the products,
we just do that.
You can at the very start of the lab. But let me finish. That's not a bad idea. That will allow you to know what's in each step. Now watch. When you put the 2 chemicals in here immediately, you're going to see some sort of reaction. You're going to describe the solid and the liquid. Now, remind yourselves of this. A solid isn't going to be like, boom, a piece of metal comes out. A solid is like if you take 2 clear liquids and you mix them together and they turn cloudy, that cloudiness is a solid. So you describe what that looks like If it looks cloudy, then say it's cloudy. If you see that it has a particular color to it, then you describe that color. Then what you're going to do is you're going to take a glass stirring rod. Can you pass me a glass stirring rod there? Okay. This glass stirring rod right here. And what you're going to do is you're going to stir in the two things together, because what will happen is when they start reacting, they'll react, and then some of the stuff on the top will not react with the stuff on the bottom. So you'll stir it in, and then if you take a look in your notes, underneath each of the steps, you see under step 4, it says observation. You're going to describe what it looks like after you've stirred in the section here. So can I be clear? In the data table, you're going to write as soon as you put the things together. Here, you're going to write after you've stirred them together. Now, after you stir them together, won't this glass stirring rod be contaminated with whatever you have in there? So you're going to wash it off, and you're going to dry it off so you can use it in the next step. Are you with me? So let's take a look here. It then says, step 5, put the test tube in the water bath from step 1. Do not let the test tube rest on the bottom of the beaker. Heat it until no more change occurs. And it tells you again what the products are. Now listen carefully. We've had 2 things happen, and this happens every single year. So some of the groups, as soon as they put this into the water, like within like seconds, boom, you're going to see a color change, and it'll be very obvious. The other groups, they put in there, and it appears that nothing's happening. So listen carefully. If you're part of the groups that you put in there and nothing seems to be happening, keep it in there and then stir every once in a while for 2 to 3 minutes with it in there boiling. And then pull it out and put it in the cold water bath. That's how we're going to cool it off. So what you're going to have is you're going to have the hot water bath, and then you're going to take tap water and put it in the 500 milliliter beaker. So once you take it out of the hot bath, you'll take it and just sit it down in the cool bath. Are you with me? What you'll discover is this. Even if yours doesn't have the dramatic color change, and in the group that may be doing it tomorrow when I'm not here, what I do is take a look at one group that has the dramatic color change, and then look and see in your test tube whether there's specks of that color. And what we discovered is that there always are, and we don't know why. It's literally the quantities of each. Sometimes you have a little bit of excess of one of the things you're mixing when you're putting them in there, and that's enough to cause the excess to kind of cover up what you should be seeing. But the lab still works perfectly, even if you don't get that pure color. Are you guys all with me on this? So after you've heated it, you'll either have it immediately turn and be like, oh, I am the greatest. Or you'll be like, sad panda, it didn't change so much. Keep it in there for 2 or 3 minutes, pull it out, cool it down, take a look and see if you see specks of color like the other groups have, but your lab is still good. Yeah? So after it's cooled down, you're going to take this and you're going to put it into your test tube rack, just sitting there. And by the way, in no cases do you take the contents of this and pour it into the beakers that you're cooling or heating with. Every year, every couple of years, I have a student that does that. Please don't. Okay. So once you have that, take a look at step number 6. It says remove the test tube from the hot water, cool the test tube and its contents for 2 minutes. That's approximate, in room temperature water. That should cool it down. Then it says add 1.5 molar hydrochloric acid to the 3rd mark. Now this part where it's parenthesized, for those of you who aren't here, you'll recognize this if when it happens. You're going to have to add more than to the 3rd mark to dissolve all the particles. And our goal is this: you're going to have some particles inside your test tube. Everyone look at me here. So after you've done heating, you pull it out. You're going to see some sort of color, and you're going to see particles. When you start putting the hydrochloric acid in, it will start dissolving the particles that are inside there. Now, what will happen is this: if you put them in there, you'll dissolve it. But if there's still particles that are sitting on the bottom, you can keep on adding hydrochloric acid, and those particles aren't going to dissolve because the hydrochloric acid isn't reaching them. So what you should do then is, and this has happened like every class, I've had like 2 or 3 groups that they've been like, but there's still stuff on the bottom, and I put so much in here. Take a stirring rod and stir it in, and almost immediately it'll all dissolve. What's happened is that the particles on the bottom haven't been accessed by the hydrochloric acid. Now, you're safe to move on to the next step when there is no solid particles still left in here. It may be colored, it may be not colored, but there's no solid in there. Can I get a head bob on that? Remember this, because when you're doing this step, you're going to add to the 3rd mark, stir. Again, you have to have your stirring rod be clean from the previous steps, right? You're going to stir, move, and then add more, stir, and then add more. Okay. Once you're done, you're going to set this back into your test tube holder. Now, the last step is you're going to take a piece of of aluminum wire. Now, if you take a look on the back cabinet or the back cabinet, on the back cart, there are these little pieces of aluminum. They're about this long. And all you're gonna do is you're gonna take it and you're gonna drop it into your test tube. You're not gonna stir, you're not gonna do anything. Now, take a look at the data table, please, again, and take a look at the bottom two rows. See where it says aluminum plus copper 2 chloride and aluminum plus hydrochloric acid? Two reactions are going to occur simultaneously when you put the piece of aluminum in. So let me remind you of this, and this will help you. When you put the piece of aluminum in, what's actually happening on the wire is the second column from the bottom. So you're going to describe what you see on the wire. Is there anything growing on it? What does it look like? What's changing? And then also what's going on in the liquid. Is the liquid changing color? Is there anything going on in the liquid? The bottom one is what's happening with gas being generated. So you're aware when you take aluminum and hydrochloric acid, you're going to end up with aluminum chloride and hydrogen gas. Hydrogen gas. You know how we know we have a gas? Bubbles. You're going to see bubbles. Do you notice how on the back on the chart here, do you see how there's a space with a line through it? That line through it means that you're not going to end up with a solid. In fact, you're not going to end up with a liquid either, but I didn't want to change the whole heading. You're going to describe what the gas is in this space. Where are the bubbles? How big are the bubbles? Are the bubbles doing anything? Are they rising? Are they disappearing? Are more forming? All that goes in there in the data table. Right?
That's what goes in the liquid portion.
That goes in the liquid portion next to the solid. Are you with me? Now, this is specifically for you guys at home because when you get to this point, I need you guys to do this. So what's going to happen is this. You're going to have the piece of aluminum wire with potentially stuff on it, and you're going to have the liquid in the test tube. What you're going to do is you're going to pour the liquid with a lot of water. Stop it. You pour the liquid with a lot of, you guys realize you cannot be goofing during lab, yeah? Those you're watching, do not play. So you're gonna pour off the liquid with a lot of water down the sink, and then you're gonna take the test tube and like a piece of paper towel, which you can grab from the side, kind of fold into like a square, and then just tap the piece of metal down and then lay it out on the piece of paper, so you can kind of observe what the copper looks like, or whatever's on the piece of metal. Although you can see that one of the products is going to be copper. Now that copper is going to be wet. They ask you to compare it to a solid copper wire. Just think of what a penny looks like, so you can describe it against a penny, and then realize if you were to let that copper dry, it would probably look a slightly different color. That wire with the copper on it, you can throw it directly in the garbage. What was the step right before we put in the aluminum? What were we putting inside the test tube? Hydrochloric acid, right? So do you realize the hydrochloric acid is also going to be reacting with aluminum? So there may still be some hydrochloric acid on the piece of aluminum when you pull it out. So don't be handling it with your hands. Just use the paper towel to hold on to the end, or if you want to have a piece of glove, hold on to it, and then you can just throw it in the garbage when you get done. Because the reality is that I'd feel completely comfortable grabbing it with my hand because the hydrochloric acid should already have reacted off with the aluminum. But let's just be safe instead of potentially sorry. Okay, any questions for me? This is kind of cool. It's like the first lab where you're going to be studying chemical reactions actually occurring. You're going to be given the remainder of class. Now the questions, these are going to be due on Wednesday. Class that is, if you're doing the lab on Tuesday, what I want you to do is I want you to turn in the lab to me Wednesday in the inbox. So sometime during the day, so you're going to have one night to do it. So turn in the box into B4 sometime during the day so I can get it because the last of the quarter ends on Wednesday. I want to be able to have some time to grade it before Wednesday. Also, you guys realize homework redemption is on Wednesday. And homework redemption for my Thursday group will have to be, or for tomorrow's group will have to be on Thursday. So any other questions here? At all times, if there's any questions you have, just stop, ask me. Goggles are on at all times. Hair back, if you can, put it in a bun, if you as long as it's not dangling, and have a fun lab. All right, begin.